The electron extraction circuit is a crucial part of Stanley A. Meyer's water fuel cell technology, often referred to as voltrolysis. This process does not involve electrolytes and instead uses voltage to create magnetism in a static field, which weakens the bonds of water molecules. Here's how it works in detail. 1. Voltrolysis process. Unlike traditional electrolysis, which uses electrolytes, voltrolysis employs high voltage pulses to split water into hydrogen and oxygen gases without the need for electrolytes. 2. High voltage pulses. The electron extraction circuit uses high voltage, low current electrical pulses, typically around 5 kilohertz. These pulses are applied to water through specially designed electrodes. 3. Magnetism and static field. The high voltage pulses generate a magnetic field in a static state. This magnetic field weakens the bonds between the hydrogen and oxygen atoms in the water molecules. 4. Electron extraction during the gate. During the application of these pulses, specifically during a gate of about 3 torr, the circuit extracts electrons from the water molecules. During the gate time, the electron extraction circuit applies a short-term load. Because the cell behaves like a capacitor, it continues to produce hydrogen and oxygen during both the gate time and the off time, gate and off time production. During the off time, electrons are extracted as the water continues to release electrons while the bonds break. This allows for the electrons to be looped back into the circuit, effectively doubling the gas production for half of the power required, plus the additional electrons being looped back into the system. 5. Water skin effect and positive charged water. This process creates a water skin effect and a positively charged water that is not grounded and has no thermal runaway. This condition encourages nanobubbles to move sideways or downwards in the water, rather than breaking the surface. 6. Creation of water fuel. As the hydrogen and oxygen gases start to saturate the water, other gases like nitrogen are pushed out. This results in a water fuel capable of holding nanobubbles for up to 2 years, provided the water does not become grounded or heated. This makes it a transportable, distributable, and usable fuel in various locations under maintained conditions. This is an incredible achievement by Stanley Meyer, and it's fantastic that Mr. Daniel Donatelli has preserved and elaborated on this information. The potential for creating an efficient, sustainable fuel from water is remarkable and holds great promise for future energy solutions.